Hi, my name is Julie Angus. I'm the CEO and co-founder of Open Ocean Robotics. At Open Ocean Robotics, we collect ocean data, providing analytics that serve a range of customers, from government to industry to research. Our USV can address three main areas of application. One is defense and security, another is environmental monitoring, and the third is hydrographic surveying. So in each of these areas, it can offer advantages compared to a crewed vessel, being able to be deployed for longer periods of time, more safely, more affordably. In bathymetric surveying, we can put a multi-beam sonar system on our vessel, allowing users to survey extremely shallow waters that might otherwise be difficult to access with a crewed boat, and even dangerous, uncharted waters. Also, often surveying these shallow waters is much more time intensive. So by being able to just deploy an autonomous boat and have it do its job, it offers not only time savings, but it makes the user's job much more appealing. In defense and security, we can offer solutions in a number of areas. We can detect illegal, unreported, and unregulated fishing, being able to allow enforcement agencies to intervene when a suspected case is detected, collecting data for prosecution, and allowing better monitoring of these vessels. We can detect other surface vessels for border security, for coastline security, for ports and harbors to provide additional protection. We can also detect underwater threats. Using our acoustic array, we can listen for very slight noises that can then be processed and reported in real time, so providing the user with real-time alerts that they can then take action on. Another area where our vessel has been used is collecting oceanographic and meteorological data. So we've put a number of sensors on for measuring ocean temperature and salinity, wave height, period, an environmental monitoring station, so weather parameters, wind speed, direction, air temperature, and also ocean currents, so an acoustic Doppler current profile for detecting ocean currents. So our boats can be operated autonomously. You can create a grid pattern for it to follow, doing the line spaces automatically, for example, if you were doing a survey, or you can direct it on a certain course, or you can tell it to loiter and maintain a precise position. But it can also be remotely controlled. So if you wanted to take over from that autonomous control, when you're on cell coverage, you can see through the 360-degree cameras exactly what's around you. So you can take a joystick and drive the boat as you would like to be able to explore certain areas or to navigate around other things. It can also go offshore because it's extremely heavily ruggedized. It can endure those extreme maritime conditions and heavy sea states. It's self-righting. It has a very innovative self-righting system. It's a passive self-righting system that uses buoyancy, a combination of the self-righting structure on the back of the vessel along with the shape of the boat means it could repeatedly capsize and right itself.